Okay, g'day. My name is Ben Gilfetter. I wanted to make a short video about the installation and running of FINIFLUX. We've had a few questions over the last couple of months about how to do this. And I've tried to have a lot of email contact, and we look at error messages, and it's always hard from an external location to really find out the problem. So I thought I'd run through a video about how to install FINIFLUX and how to run it for the first time. First of all, FINIFLUX is a model that was programmed by my colleague Sven Frey. And together we kind of developed this model and have used it in quite a few different catchments to quantify groundwater discharge using Radon. It seems to work pretty well in most cases. And yeah, we hope that other scientists will use this model. It's quite an advanced model compared to some other methods that are out there for their research. But of course, the model needs to run and needs to be installed, so that's the idea about this video. Okay, I think we'll start off with downloading the FINIFLUX 2.0 model from our web page on the screen. Hopefully you can see the web page. We have a tab where it says software. We click on that. We have a few different kinds of models here, but today we're only interested in the FINIFLUX model. You can go on here. We have a bit of a description of FINIFLUX, a small update. Hopefully I'll put the video on here after the video is finished running. And we have the thing to download FINIFLUX. This is a zip file. So first of all, you need to put in your details, simply that we know who is running FINIFLUX, and if there is any bug identified or any major updates, we can let the people know about that. So I can put in my details to start with. I think it's currently in German. I'll just switch it into English. Okay, this is a bit clearer. Start with Gilfetter. Put in the email address. I guess this is the same. And we're located in Bayreuth. So once you do this, you should be able to accept agreement. This is simply that you don't use it for commercial commercial things, I guess. And save that. Then we can download the zip file. Okay, so here we have the zip file for FINIFLUX. This is something we can click on. I'll move this over onto the screen. I have a thing for unzipping files. I'm not sure if this is something old and you still need this. I'm guessing Windows does it these days, but for whatever reason I still have this program for unzipping zip files. I'm going to put this file on my D drive. I have the most space. Downloads. Where is the D? Computer. Maybe I just put it straight on the D drive. Okay, that's now been extracted. Let's have a look on the D drive if it's actually there. Look on D, FINIFLUX, you see it here, FINIFLUX 2.0 2022. So we did a small update last year just to fix one of the degassing equations. So when you click on this, you can kind of see what's in this FINIFLUX folder. So traditionally, we used to have this install FINIFLUX program that downloads the DLL files from MathWorks. So from this programmed in MATLAB, and then we compiled it with MATLAB, and there's certain DLLs that need to be installed that the FINIFLUX will run. This hasn't been working for the last 6 months to a year for some reason. We can do this now. I'll just show you the error message that comes. Okay, it's thinking. I'm still running Windows 7, so might look a little bit different to you if you're running Windows 10 or 11. Okay, we just put it again on D as well. I'm guessing this is not going to work, so I'm just going to put it on D, select, next. Okay, so this is the classic error. It says it can't connect to MathWorks. We don't know why this is actually. We haven't found any errors on the internet or on help forums why it's not connecting to MathWorks, but it's something that we've observed. So this has to be cancelled. This means that the DLLs for FINIFLUX are not installed and the model won't run. So what we need to do is go to let's put in MATLAB runtimes. Okay, this is the MATLAB runtime. So the install FINIFLUX simply goes here and downloads these runtimes, and we need 2015B 64-bit. It's important at 64-bit. The FINIFLUX only works with 64-bit. We disabled the 32-bit because it seems that no one had these computers anymore. So if we go on 64-bit, this will be downloaded. You can see it here. It's quite a big file. Just so you know, it takes some time to both download and install the DLLs. And what's also, now I'll talk about that later. We just have to wait for this to download. Okay, there you go, we're done. We can click on that to start the installation process. You see my computer is also not the quickest. Yep, I'll install that. Okay, so the installation process is actually happening on my other monitor. I'm not sure if I can switch over. No, that doesn't work. Something strange happens. You have to believe me that it's installing, I guess. Still installing. Get this. That should look like this. This is going to take a little while, so I might pause the video while this happens. Okay, we're now at 88% installed. Hopefully the last 10% goes quickly, and then we can move on. It took about 5 minutes on my computer. Depending on your internet connection, could take, I think, between 3 and, let's say, 20 minutes. Okay, that means the DLLs are finished. So now what's really important, now we've done this, we don't need to do the install FINIFLUX application anymore. What we've just done is essentially a manual way of doing this install FINIFLUX program, and we don't need to do that anymore. So once we've done this, we can actually move on with starting to run the model to check if everything has been installed properly. If I just talk about these different folders, we have the executables in this file. These are the executables, the exes. We also have the source code, if you're interested in that, in this file here. If we look at the FINIFLUX, for example, you can have a look at the source code for FINIFLUX. This is a MATLAB file. You can open it as text, as you see here. Yeah, there's nothing that special in here. One interesting thing maybe is the degassing. You can see here is how the K is being calculated for the degassing internally in FINIFLUX. So if you use a value of 1, you get this equation. If you use a value of 2, you get this, or if you value of 3, then you use your own degassing. Okay, that's not what we want to look at today. It's just most of today is about installing FINIFLUX and getting it running. So now the best way to test it is look at the example data sets. So we have the Avon, we have the Selka. The Avon River is a river in Australia where radon works really well as a tracer because we have a dry environment. We simply only have groundwater input into a stream. We don't have any tributaries. Anything more complex like interflow is also not taking place because pretty much all these sources have dried up. If you look onto the Avon folder, we see we have these files here. The most important one is this FINIFLUX Excel file. If we have a look at this, this is to explain pretty well, or I hope pretty well, in the instructions for running FINIFLUX what all these different things are. This, for example, observation points in meters along the river. We have the measured radon concentrations, reach number, the reach length, so the distance between two sampling locations. The river depth is important, river width, and I think the rest is pretty explanatory. Of course, the groundwater end member is important as an important parameter. You can change this for each reach, so you can have a different end member for each reach if you have this data. One important little thing is that in this column, this is the user-defined degassing. This has to be set, has to have a value in there. Even if it's not being used, it has to have a value in there. Otherwise, the model looks in there and says there's no values and doesn't run. So if you're taking one of the degassing parameterizations from FINIFLUX, just put a 0 in here. Otherwise, calculate your own degassing in meters per second, and you can also put it into this column. The most important thing is here to run the example data set is this here. You need to have the exact path where FINIFLUX is running. This is often what I still forget even sometimes, and I find that there's nothing being produced by FINIFLUX, then I have forgotten to update the path. This is probably the most common problem that we have. Another thing to look at is the number of CPUs. So this is the more CPUs that you use, of course, the quicker that the model runs, because you have more slaves. We have the degassing model in this case, we have 2. The standard model we use is usually 1 hyperexone on or off. The kind of residence time distribution that the model uses, we usually use a power law residence time distribution, but you are free to decide this. If you use a gamma model, you have to give a value here for what kind of gamma. 0 is not a good parameter. 0.5, I think that tends to be similar to the exponential model. And upstream weighting, this is something you can play with. 0.5 we found works pretty well. So I'm just going to look at the path where I've just downloaded FINIFLUX. Let's see, that's here. I'm going to copy and paste that into here. Okay, and I'm going to save that, close it. Another FINIFLUX file that we're not going to look at today. And then go back to here. This is where we have our FINIFLUX folder. So the most important, or what we need to do now, is to run the model. So we filled out all the Excel file with all the data. Since this is the example file, it's all been done for us. If you use your own data, of course, you have to fill it out for yourself. So what we're going to do here is run the pre-test. So you can see this is in German. I'm not actually sure what the English word is for this. This means open the DOS box, pretty much. You need to open the DOS box. So in 2007, this still works. That we can open the DOS box like this. This is really good. I'm not sure why they got rid of it in 2010, or Windows 2010 and 11. That's pretty annoying. But on 7 it still works, which is nice. But most of you probably won't have this anymore if you're not using Windows 7. So the other way to do it is you go to your Start menu of Windows and you type CMD. And if you do that, you get something looking like this. And now you need to navigate to your folder where all this FINIFLUX stuff is. So first of all, we need to go to the D drive in my case. And what I can then do is copy the path. And then do CD. I can then paste the path in. And then now we're in our example data sets. So then we need to go into Avon. And then I'm going to get that, everything's in there. Then we can do pre-paste. And this sets up the model to run. So it copies all the stuff out of the Excel file, produces the slaves that we need to run the model, and yeah, pretty much gets everything ready to start. This can take a few seconds, depending on the speed of your computer in this case. See, my one's not that quick. Okay, then you get this screen. You didn't see it, but you could see it kind of writing this different stuff into the folder. We can use this screen later on, so I'm not going to close this right now. But first of all, what we have to do is check that there's something in the slave. So you look in the slave. If you haven't done the path right in the Excel file, then you look in the slave and you'll see that there's nothing in here. But I did do the path right, luckily, so now I have all this stuff in the slave. That's good. That means the model is ready to run. Let's go back here. And first, we need to start the master. So the idea of slave and master, we have the master that controls and analyzes all the data that's calculated by the slaves. It also tells the slaves what to calculate. So this is the idea of parallel processing, that we can use multiple CPUs to work on the data to speed things up a little bit. And the master kind of controls what all these different CPUs are actually calculating and putting it together, analyzing the data and to see what needs to happen there. So we're going to go BioPest 64, FINIFLUX, H 4004. I think that's right from memory. Okay, so you might get this from your Windows firewall asking if this is a safe program. Pretty sure FINIFLUX is safe. So what you can see here is that you see running model for the first time, waiting for one slave to appear. So the model is waiting for a slave to appear to do the work. In this case, I only have one slave. I could have had more slaves, which would have made things go quicker. But just for this example, I will just use one slave. So we have to go into the slave. And then we do something similar. FINIFLUX. So now the difference is I need to put in my computer name. From memory it's that, and then 4004. This kind of shows the slave where it's working. Okay. Slave is running the model. So if all goes well, this will run the model and deliver the data from the first model run to the master. There's also the speed test. You can see how quick your computer is. Probably quicker than my old machine. This is a good sign. It means the model is run one time, calculating Jacobian matrix and all this other stuff that usually Sven understands much better than me. So now the model is going to run and fit the FINIFLUX model to your observed radon concentrations. And this is something that we can observe, this process we can observe to see how well it's working and how far the model is progressing. To do that, we need to start the pest tracker. So I'm going to do it the easy way. You might have to do it with the CMD again. I'm going to open another box here. Here, write pest tracker. Hopefully I spelled it correctly. And And this is a plotting program that kind of plots what FINIFLUX is doing at which time. Okay, sometimes it can take some time to start, particularly the first time. Okay, I'll put this over here. So there's one thing that we could never work out. You have to click in here to get the model results. So I just click in this. Exactly. So what we have here is the measured radon data. This is these little, I'll put that in full screen. This is these little radon, or these little circles here. We have kind of a hotspot of groundwater discharge in the middle of the catchment. But what's interesting is we also have here for the model run. This is the first model run using this groundwater discharge. So it starts with the groundwater discharge as initial value of 1 times 10 to the minus 5 meters cubed per meter river per second. This is a bit of a strange way to write the unit meters squared per second. Really, it's meters cubed per meter river length and second. And so what FINIFLUX is going to do now is modify these groundwater inputs for every reach here to get a good as fit as possible between the model and the measured data. If I keep on clicking in here, we should get an update on the model data. Okay, so this is another run of the model where it has changed the groundwater inflow and got another fit. Of course, it's not very good at the start. This takes maybe an hour or even longer to get a fit between the measured and the model because it's an iterative process. What you see here is a correlation coefficient between measured and modeled, and this is kind of what the model is trying to optimize that, changing the groundwater inflow until we get as good a fit as possible between measured and modeled data. Okay, that's kind of it for the installation and running of FINIFLUX. Hopefully that's going to help to get people on the right track and at least get the model running. Of course, you can ask us if there's any problems or any questions. We hope that people use the model. Maybe this helps to do that. Okay, then I hope you have fun with FINIFLUX and get some nice results from your radon monitoring in streams.